This is the dividing radical worksheet. We had a lecture on this topic and now we're working on the homework video here. So let's go back and recall what we're doing. Dividing radicals is also known as rationalizing the denominator. So you see a fraction here, and the denominator is a square root of 2. That's an irrational number. We want to actually have a rational number in that position on the bottom of the denominator. So we're going to use some ideas here that we had in the last video and that we discussed in class. And the idea is that the square root of a triangle, if we remember, the square root of a triangle times the square root of a triangle by the product rule gave us a triangle. In other words, if you multiply a radical, and here's what I'm saying, what's under the radical is that triangle. What's under the second radical is the same thing, the exact same thing. By the product rule, we get a perfect square. We find that we get it equal to this triangle without the radical. Now that's the whole idea. There is no, over here, there's no radical. So we're going to use this idea that the square root of 2 times the square root of 2 is simply the number 2, and there is no radical. That's one key idea we're going to use here in general. Now, okay, we're also going to use a couple of facts here just to talk about this, that anything times 1 is itself. Okay? Anything times 1 is itself. And also, just to point out to people, that if I have any number divided by itself, as long as that number is not 0. So I sometimes describe this as, a heart divided by a heart is the value 1 as well, meaning anything divided by itself is 1. These are some ideas we're going to use here to rationalize the denominator. This is the key idea here. And let me go through this process and express to you how this really works with these ideas, like we did in class, because we're going to do this for our homework. We're going to write it this way, just so you guys know. Isn't it true that 1 over the square root of 2 is equal to 1 over the square root of 2? In other words, any number is the same as itself. Now here's where these ideas come into play. This is also true. Any number times 1 is equal to itself. And then now what I'm going to do here is the following. I'm going to say, okay, 1 over the square root of 2. I'm now going to use this idea right here. Here's what I'm saying. I'm going to multiply both the top and the bottom by the square root of 2. The reason we use the square root of 2 here is because whenever we multiply fractions, we multiply horizontally across, so that what you end up getting here is 1 times the square root of 2 for a numerator, and then you get the square root of 2 times the square root of 2 for the denominator. Let's kind of write this a little better. It's getting down here. 1 times the square root of 2. Square root of 2 times the square root of 2. And so if we look at our work, let's put it right up here. 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 is actually 2. What you're seeing here is an equivalent fraction where the denominator no longer has a radical. We have rationalized the denominator, and these are the same values. So we're going to use these ideas here to rationalize our denominator, and that's actually the process that you see here. We're going to use this over and over again, and for some of these in our homework, for at least the terms that have only a single radical in the denominator, this is the process. So let's see this again and again and again. try number 3. We have 4 over the square root of 5. And we're going to try to get rid of this radical in the denominator. And that's going to be 4 over the square root of 5. We're going to multiply the top by the square root of 5 and the bottom by the square root of 5. Now we multiply fractions horizontally across, so we can end up with 4 times the square root of 5 over the square root of 5 times the square root of 5. And we know this is going to be simply 5. And you're done. There is no radical in the denominator. Number 5. 4 over the square root of 7 is 4 over the square root of 7. Multiply the top and bottom by the square root of 7, because this number is really 1. We're going to multiply horizontally across. So we end up with 4 times the square root of 7 over the square root of 7 times the square root of 7. 4 times the square root of 7 over the square root of 7 times the square root of 7. Here's where we're focusing on again. Square root of 7 times the square root of 7 is simply that 7. We've rationalized the denominator. Number 7. 2 over the square root of 3 is the same as 2 over the square root of 3. Multiply it by the square root of 3 over the square root of 3. And notice, 2 times the square root of 3 over the square root of 3 times the square root of 3. The reason we use the square root of 3 here is because the square root of 3 times the square root of 3 is simply 3. There is no radical anymore. And you're done. Number 9. The square root of 2 over the square root of 3. That's the same as the square root of 2 over the square root of 3. Multiply 2 square root of 3's. We get 2 times the square root of 3, or, let's go back, the square root of 2 times the square root of 3, over the square root of 3 times the square root of 3. Again, the numerator is the square root of 6, while the denominator is 3. Because I got the square root of 3 times the square root of 3 is just going to be that 3 again. Now that square root of 6 radical is actually simplified. So that means we're done. This is the square root of 6 over 3. And I'm going to say something here to you, by the way. We can't divide 6 with 3. In other words, sometimes students try to think that, oh, this is 6 divided by 3. In other words, my radical here on top gets confused with the quotient rule. 6 under this radical cannot be divided with the 3 that doesn't have a radical. There is no radical for that 3. Quotient rule is simply the square root of a triangle over the square root of a square. The square root of a triangle over a square by the quotient rule. Pardon for the cars. The point is we can't divide the 6 with the 3. They both have to have radicals. So we're done. Number 11. The square root of 5 divided by the square root of x. Square root of 5 divided by the square root of x. We're going to multiply both top and bottom by the square root of x. So that what we get here, again, when we multiply our fractions, is the square root of 5 times the square root of x over just the x. Now the square root of 5 times the square root of x is the square root of 5x. So let's be clear. The square root of 5x over x is what you see. Again, you are not able to cancel the x's out. In other words, do not think that these two x's go away. That's not true. The reason it's not true is because you don't have a radical in the denominator. So in other words, you cannot simplify, and you're done. Number 13, the square root of 2 over the square root of 10. Same process. Multiply both top and bottom by that square root of 10. What you end up with here is the square root of 2 times the square root of 10 over the square root of 10 times the square root of 10. The square root of 20 over 10. Now, my radical square root of 20, this can be simplified. So we're going to have to simplify this. So let's notice that the square root of 20 is written as, here, let's simplify. 20 is divisible by 4. That's the largest perfect square that goes into 20. Product rule, square root of 4 is 2 times the square root of 5. So this is going to be 2 times the square root of 5 over 10. Now, here's the deal. Take a look at what's going on here. I have 2 and I have 10, and there's an operation between my 2 and my square root of 5, and that's multiplication. The point is, I can simplify the fraction 2 over 10. I can actually write 10, if you recall, as 2 times 5. In other words, my 2's are going to go away, and my final answer is going to be here. The square root of 5 divided by 5. I cannot cancel these 5's because there's no radical in the denominator. So this is a simplified answer, and we have to simplify. So let's write it a little bigger and say that the square root of 5 over 5 is our answer. This is number 13. Number 15. The square root of 3 over the square root of 6. Again, multiply both top and bottom by the square root of 6. We get the square root of 3 times the square root of 6 over the square root of 6 times the square root of 6. The square root of 18 over 6. We can simplify the square root of 18. Nine is the largest perfect square that goes into 18, so this is 9 times 2. Product rule, square root of 9 is 3. I'm going to replace my square root of 18 with 3 times the square root of 2. 3 times the square root of 2 over 6. Again, we can only simplify the fraction 3/6. Now, some people will say that, you know what? Well, let's actually do it the way I do it. 6 is written as 2 times 3, so that my 3's are canceled. I use prime factorization to simplify my fractions most of the time. And again, my 2 does not cancel with the numerator and the denominator because the numerator is square root of 2. There's a radical for the top number, not for the bottom, so you're done. This is number 15. 17. 1 minus the square root of 2. Over the square root of 7. This process works exactly the same way. Even though the numerator has a difference of terms, we're still rationalizing the denominator, getting rid of the radical on the bottom. We're going to multiply by square root of 7 on top and bottom. This gives us 1 minus the square root of 2 times the square root of 7 over this 7. Now, by the distributive property, we're going to distribute. We end up with the square root of 7 minus the square root of 14 over our 7. So we can write our answer this way, or we can actually distribute the division by 7. That is, write the 7 under both terms. And this is also often used as an answer. So either would be fine. Number 19. 3 plus the square root of 2 over the square root of 6 is 3 plus the square root of 2 over the square root of 6. Multiply by top and bottom by that square root of 6. There's a parenthesis here. We're going to eventually distribute 3 plus the square root of 2 times the square root of 6 over the square root of 6 times the square root of 6. We know that's going to be 6. We're going to distribute. So 3 times the square root of 6 plus the square root of 12 over our 6. Notice that the square root of 12 can be simplified. We simplify this as 4 times 3, the square root of 4, square root of 3, or 2 times the square root of 3. 3 times the square root of 6 plus 2 times the square root of 3 over 6. This is an answer, but very often we actually are going to distribute that division by 6. 6 is dividing both terms. And you notice that I might break down my 6 into the product of its primes as 2 times 3, 2 times 3. A 3 goes away here, and a 2 goes away here. That 2 is left on the bottom, the 3 is left on the bottom. So your final answer is going to be the square root of 6 over the 2 plus the square root of 3 over 3. And we're done. (21) 4 minus the square root of 15 over the square root of 3. 4 minus the square root of 15 over the square root of 3. Square root of 3 over square root of 3. We're going to distribute. We get 4 times the square root of 3 minus the square root of 45 over 3, because that's what square root of 3 times square root of 3 is. Notice again, the square root of 45 can be simplified as 9 times 5, square root of 9, square root of 5, 3 square root of 5. 4 times the square root of 3 minus 3 times the square root of 5 divided by 3. Distribute the division by 3. Let 3 divide both terms, and you notice the 3's cancel. 4 times the square root of 3 over 3 minus the square root of 5. And you're done. (23) 1 plus the square root of 7 over the square root of 2. 1 plus the square root of 7 over the square root of 2. Square root of 2 over square root of 2. 1 plus the square root of 7 times the square root of 2 over 2. And we're going to distribute. We end up with the square root of 2 plus the square root of 14 over 2. And we're done. (25) 1 over the square root of 2 plus 1. This problem is done by multiplying both top and bottom by the conjugate, if you recall from lecture. The conjugate of square root of 2 plus 1. Okay, so the conjugate of the square root of 2 plus 1 here, and it doesn't matter which square root of 2 plus 1 you look at. If we want to say, okay, square root of 2 plus 1, the conjugate, again, is the same first and last term or first and second term here. The only difference is that the sign is opposite. So the opposite of a positive sign is a negative sign here. So this is what we call conjugates. They're different terms. They only differ by the signs that are between them. So I'm going to multiply top and bottom, okay, by that square root of 2 minus 1. And then I get 1 times the square root of 2 minus 1 over the square root of 2 plus 1 times the square root of 2 minus 1. Now remember from class that there's a conjugate formula. We only multiply the first terms and the last terms because the O and I terms cancel. So what this means is the following. 1 times anything is itself. So I have the square root of 2 minus 1 in a numerator. The square root of 2 now, here's my first terms. Square root of 2 times square root of 2 is actually 2. And then I'm going to say positive 1 times negative 1 is negative 1. This is what happens when we multiply conjugates. You end up with the square root of 2 minus 1, and 2 minus 1 is 1. Anything divided by itself, or I should say anything divided by 1 is itself. So the square root of 2 minus 1 divided by 1 is actually the square root of 2 minus 1. And you're done. (27) 1 over the square root of 3 minus 2, square root of 3 minus 2. Again, we're going to do what we did up here. This is a difference of two terms. We're going to multiply by the conjugate. Square root of 3 plus the square root of 2. Square root of 3 plus the square root of 2. In the numerator, 1 times anything is itself. And again, in the denominator, we have to take minus the square root of 3 times minus 2. Let's hold on. Let's mute. Okay, let's make a correction here. The conjugate of the square root of 3 minus 2 is the square root of 3 plus 2. Square root of 3 plus 2. So let's write down everything here. 1 times the square root of 3 plus my 2 over square root of 3 minus 2 times the square root of 3 plus my 2. 1 times anything is itself. Now here we go. We're going to do the same thing we did here. Square root of 3 times square root of 3 is 3. Negative 2 times positive 2 is negative 4. So I get the square root of 3 plus 2 over negative 1, which is going to give me negative square root of 3 minus square root of 2. Divided by a negative 1 changes both of the signs. And you're done. (29) 3 over the square root of 5 minus 2. Again, multiply by the conjugate here. Square root of 5, 2, square root of 5, 2. We're going to add. The conjugate is what you see here. So, here we go. 3 times the square root of 5 plus 2 over the square root of 5 minus 2 times the square root of 5 plus 2. Let's actually clean this up a bit. Okay, hold on for a second. Here we go. 3 times the square root of 5 plus 2. Square root of 5 minus 2. Square root of 5 plus 2. 3 times the square root of 5 plus 6. When I distribute in the numerator, distribute. The denominator now, I take the square root of 5 times the square root of 5, which gives me 5. I also take minus 2 plus 2, which gives me negative 4. So I get 3 times the square root of 5 plus my 6 over 1, because 5 minus 4 is 1, which is 3 times the square root of 5 plus 6. (31) negative 3 over the square root of 6 plus my 2. Negative 3 over the square root of 6 plus 2. I need to multiply top and bottom by the conjugate of the square root of 6 plus 2, which is the square root of 6 minus 2. The square root of 6 minus 2. Okay. Negative 3 times the square root of 6 minus 2 over the square root of 6 plus 2 times the square root of 6 minus 2. Square root of 6 times square root of 6 is going to be multiplied together. Well, let's actually do this consistently. So, negative 3 times the square root of 6 plus 6 by the distributive property for the numerator. The denominator is FOIL, but it's multiplying by conjugates. First term, the square root of 6 times the square root of 6 is 6. A positive 2 times a negative 2 is going to be a negative 4. Positive 2 times negative 2, negative 4. We get minus 3 times the square root of 6 plus 6 over 2. And we are going to divide both terms by that 2. Now 6 over 2 here can be replaced with the value of 3. So my final answer is going to be simply what you see here. This negative 3 and the 2 for my fraction does not simplify, and so you're done. This is number 31. Number 33. Is 1 over the square root of 6 plus the square root of 2. Let's be careful. One over the square root of 6 plus the square root of 2. Again, we need the conjugate of the square root of 6 plus the square root of 2. We're going to multiply top and bottom, square root of 6, square root of 2, by the conjugate. They differ in sign. Now, one times the square root of 6 minus the square root of 2 in the numerator over the square root of 6 plus the square root of 2 times the square root of 6 plus the square root minus the square root of 2. So we're multiplying by conjugates. Notice again here, this is what we're saying. Plus, minus. Conjugates. One times anything is itself, so I get negative 6 minus the square root of 2. And let's pay attention here. My first terms, negative square root of 6 times square root of 6 is just 6. And then I have positive square root of 2, negative square root of 2 is negative 2. So I get square root of 6 minus the square root of 2 over 4. This is acceptable as an answer, but we can distribute the division, and we are done. So either would be okay. It's number 33. Number 35 is 3 over the square root of 5 minus the square root of 2. This is equal to 3 over the square root of 5 minus the square root of 2. Once again, we need to multiply by the conjugate. Square root of 5, square root of 2, square root of 5, square root of 2. That is, the conjugate of this difference will give us a plus. Take a look. Our sign here, I guess we have to change the color. It's negative, positive. These are conjugates. Okay. 3 times the square root of 5 plus the square root of 2 over the square root of 5 minus the square root of 2 times the square root of 5 plus the square root of 2. We're going to distribute. We get 3 times the square root of 5 plus 3 times the square root of 2 over square root of 5 times square root of 5 is going to be 5. Minus square root of 2 plus square root of 2 is going to be minus 2. 3 square root of 5 plus 3 square root of 2 over 3, because 5 minus 2 is 3. Divide both terms by the 3. Distribute the division by 3. We get cancellation. Final answer is the square root of 5 plus the square root of 2. 37. 3 over the square root of 7 plus the square root of 5. 3 over, let's try it this way. 3 over the square root of 7 plus the square root of 5 times the conjugate, the square root of 7 minus the square root of 5. So again, notice we're multiplying by, if we look at the details, plus, minus. Conjugates. Three times the square root of 7 minus the square root of 5 over the square root of 7 plus the square root of 5 times the square root of 7 minus the square root of 5. Distribute in the numerator. 3 times the square root of 7 minus 3 times the square root of 5 over the denominator. Let's take a look. The square root of 7 times the square root of 7 gives us a 7 for our first term. Positive square root of 5 times the negative square root of 5 gives us a negative 5 for the last term, because the O and I terms cancel in FOIL. We have 3 times the square root of 7 minus 3 times the square root of 5 over 2. Distribute your 2. Distribute that division of 2. 3 square root of 7 divided by 2 minus 3 square root of 5 divided by 2. Let's write that 3 better. Minus 3 square root of 5 divided by 2. And we're done. (39) The square root of 5 over the square root of 3 plus 4. Square root of 5 over square root of 3 plus 4. Now multiply top and bottom by the conjugate of the denominator. Square root of 3 minus 4. Square root of 3 minus 4. Notice again, plus, minus. Conjugates. Square root of 5 times the square root of 3 minus your 4 over square root of 3 plus 4 times the square root of 3 minus 4. In your numerator, you're going to distribute. We get square root of 15 minus 4 times the square root of 5. In the denominator, we multiply our first terms. Square root of 3 times square root of 3 is just 3. And then we multiply the last terms. Positive 4 times negative 4 is negative 16. So we get square root of 15 minus 4 times the square root of 5 over a negative 13. Now, we can keep that as an answer, but we could write it a little better. See this negative sign here? One thing we could do is we put this at the same level as our division sign. So we get the square root of 15 minus 4 times the square root of 5 over 13, and it's also written that way. So here's another way to write our answer. Some books will write this as, they're going to distribute that negative sign on top. So you're going to get negative square root of 15 plus 4 times the square root of 5 over that 13. Here's a third way. My preference is the second. My preference is what you see over here. (41) Square root of 6 over square root of 3 plus 2. Square root of 6 over square root of 3 plus 2. You're going to multiply by the conjugate. Square root of 3 minus 2. Square root of 3 minus 2. Notice again, plus, let's go back. Notice what's going on here. Plus, minus. These are conjugates. square root of 6 times the square root of 3 minus 2 over the square root of 3 plus 2 times the square root of 3 minus 2. In the numerator, distribute square root of 18 minus the square root of 12 over square root of 3 times square root of 3 is going to be 3. Positive 2 times negative 2 is negative 4. So we get the square root of 18. This is getting a little more difficult to write. Square root of 18 minus the square root of 12 over negative 1, which gives us negative square root of 18 plus the square root of 12. Let's write this down here. Negative square root of 18 plus the square root of 12. And I can simplify my radicals. This is negative square root of 9 times 2 plus the square root of 4 times 3. 9 and 4 are perfect squares by the product rule. Negative square root of 9 times the square root of 2 plus the square root of 4 times the square root of 3. Negative 3 square root of 2 plus 2 square root of 3, often written with the positive term first. So we just rewrote our terms here with the 2 square root of 3, which is positive first, and then that minus 3 square root of 2, which is negative, we wrote that second. So either way would be fine as an answer, but I prefer, again, the second one. And I guess this is number 41. And that leaves us to 43. Square root of 5 minus the square root of 3 over square root of 3 plus the square root of 2. Again, here's what you're going to do here. You're going to multiply both top and bottom by the conjugate of the denominator. So notice again, we got plus and minus. These are conjugates. Square root of 5 minus the square root of 3. Square root of 3 minus the square root of 2 over square root of 3 plus the square root of 2 times the square root of 3 minus the square root of 2. This is going to be an interesting problem because the top we get to use FOIL. The bottom we're multiplying with our conjugates. So the bottom will be the easier computation. You know, when you multiply with conjugates, you're multiplying with that square root of 3 times square root of 3. And you'll end up with, as a fraction, that 3. And then you got this positive 2, a square root of 2 times a negative square root of 2, which gives us a simply negative 2. Now that's kind of nice because 3 minus 2 is 1. So the denominator is 1 here. So the only work we really have to do, let's kind of make it cleaner. 3 minus 2 we know is 1. So the only work we're going to do in this problem is going to be square root of 5 minus the square root of 3 gets multiplied to the square root of 3 minus the square root of 2. So let's do that. The square root of 5 minus square root of 3 times square root of 3 minus square root of 2. Okay? We're going to have to use FOIL. So let's get out the FOIL box. The square root of 5 minus square root of 3. The square root of 3 minus my square root of 2. Square root of 5 times square root of 3 is square root of 15. The square root of 5 times minus square root of 2 is minus square root of 10. Minus square root of 3 times square root of 3 is minus 3. And minus square root of 3 times minus square root of 2 is minus square root of 6. Write down our terms. Square root of 15 minus the square root of 10 minus 3 minus the square root of 6. Now notice these terms here are not like. We cannot combine them. And so this was my numerator from the prior problem. Right here. This is our numerator. And the denominator is actually 3 minus 2. This is 1. So anything divided by 1 is itself. What that means is this is my final answer. I can divide by 1, but that doesn't do anything. It's still what you see. Square root of 15 minus the square root of 10 minus 3 minus the square root of 6. You are done. This was number 43. And that's it.